MAUDE is a user-friendly platform that simplifies the design and analysis of complex systems, such as networks of medical devices in a hospital. It allows users, including those without expertise in modeling languages, to employ advanced model-based engineering analysis tools to create safe and secure systems that balance properties such as power usage, network capacity, processor speeds, and data protection. Built for a wide range of stakeholders, from IT security specialists to healthcare providers themselves, MAUDE automatically generates customized dialogues that walk the user through system design and analysis. The following examples show how MAUDE can be used to manage devices in a hospital setting, allowing the user to consider all ramifications of adding a new device to the facility. For this example, we're going to show the MAUDE dialog for helping the user add a new device. We start out with a library of devices that we can select from, and for this example, we're going to select an EKG to add to their facility. We select Next. Now we need to select where in the facility this device is going to be added. Within our particular hospital model, we have 2 different floors. So we're going to go to the second floor. And the second floor has 3 different rooms. We're going to select room number 2. And we'll select a bed within that room. And then we'll go to the next dialog. We now have to select a network selection. Under the bed, we have 2 different options. There's a wireless network or just a regular network. And we'll use just the regular patient network. The next dialog asks us about electrical interfaces. We have 2 options here. One is an electrical bus with a standard UPS that is backed up for life-critical systems, and the other is just a standard electrical bus. Since this is not a life-critical device, we're going to select the standard bus. Then we need to select a medical application processor. For this option, there's only one, so we'll select that and continue on. For each of the devices in the library, there are a number of properties that can be set. The device comes with defaults from the library. So for this EKG, we can select the period, which is how often it sends out data, or we can work with the power. So for this particular device, it's a little bit faster than the default in the library. So we're going to change the period. And we're going to change the power. This uses a little bit more power than the standard device in the library. So we make those changes and select Next. Now it's time to select the analysis that we're going to run. There's a number of analyses that are selected by default based on the task that we're doing right now, adding a device. But since we changed the timing on one of the devices, we're also going to add in a timing analysis. We can then select Add Device and Run Analysis. And now is where MAUDE is actually making changes to the model. And it tells us the changes that have been made. It's added the new device, it's added connections to the map and to the network and also to the patient. We can select OK, and MAUDE is now running the analysis. We select this icon to get updates of our analysis results. So now we can see that we've got our analysis results back, and the green arrows show that all of our analysis has passed successfully, meaning we have not violated any of our set requirements. Now let's go back and try adding another device to this room. So select Complete. We're going to select the Add a Device process. This takes us back to our starting screen. We're going to select Next. And now for this example, we're going to add a PCA pump. Select the PCA pump, select Next. We're going to keep it in the same room, in the same bed, so we can take the defaults for that. Keep it connected to the same network and the same electrical bus, and keep it connected to the map. We're not going to change any of the default properties for this device, so we can just select Next. Now we're ready to run analysis on this device. We'll select our timing analysis again, just to make sure that nothing has changed. It tells us our changes to our model. See that we've added this new device and connections to the patient and the networks. And we'll go ahead and run the analysis. We can see over here that our analysis results are now out of date because we've changed the model. So we'll ask for new analysis results. And now we can see that a couple of our analysis has failed. These red X's show that there are some errors. We can dive a little bit deeper into this. So we're going to select our separation analysis and get a little more detail. And what it tells us is that the PCA pump in bed 202, which is the room that we just added it to, is violating some of our isolation domain requirements. Our library does not allow this device to be connected in the same network as some of the other devices, and so this results in an error. This is the kind of error that our separation analysis can give us information on. The designer could now potentially go back and select a different device or potentially put in some separation in the network design. Now I want to jump into the model and just show how MAUDE made changes to the AEDL model all behind the scenes. So this is what the AEDL model looks like. And if we scroll down and look at room 202, we can see that MAUDE has added subcomponents for the EKG and the PCA pump, made connections for all the electrical and all the network connections, and also added some properties. All of these changes were made by MAUDE behind the scenes without the user having to interact with the model at all. These examples show how MAUDE can assist health professionals in tasks like adding devices, setting properties, and performing analysis in a hospital model. Beyond healthcare, the MAUDE infrastructure and user interface supports model-based development and analysis for any setting that involves complex cyber-physical systems. This includes applications such as aerospace, automotive, and medical device development.